All right, we are looking at a lesson here on the complex number system. This is really when it comes to the skill of comparing and ordering real numbers. We're really going to look at comparing real numbers, classifying real numbers, and everything. And to do that, we have to identify what we call the complex number system. If you think about all the numbers that you've ever learned about, the very first ones that we started with were our 1, 2, 3, 4. You know, when you're a little kid and you're like, how old are you? And you're like, I 1, 2, 3, I'm 3 years old. I'm 3 years old. All right, and you learn about these different numbers at a very, very basic age. 1, 2, 3, 4. How many apples do you have, Johnny? Oh, well, I have 4 apples. Thank you very much, Alex. All right, so as we're looking at these are the basic numbers. These are known as our natural numbers. All right, our natural numbers, as we come across them, 1, 2, 3, 4, they're whole numbers that are above 0. So what about 0? Well, 0 we did learn about as well, but maybe that wasn't your first number you learned about. 0 comes into play along with 1, 2, 3, 4, 5, and it's known as what we call a whole number. Now, notice I have a concentric circle here. All right, when I've got that concentric circle, that means that what is inside of one circle contains everything. So as we look at this, a natural number like 1 is a natural number and a whole number. But 0 is just a whole number. All right, 0 is just a whole number. 0 is not inside the circle of natural numbers. So whole numbers includes every single number you see right here. It's 0, 1, 2, 3, 4, 5, 6, 7, and so on. All right, what about beyond that? What about other numbers that aren't positive or 0? Well, then we get into our negative numbers like -3, -2, -1, and so on. All right, these numbers, they seem like whole numbers because they don't have decimals, but they're not technically part of the whole number system. They're actually referred to as what we call integers. Integers now include all of these. Every single one of those is an integer. -3 and beyond, all the way down into infinity, all the way up through +5 there. They're all integers. It's basically every number, both positive, negative, and 0, that does not have a decimal value attached to it. All right, so that would be our integers. So what about decimals? Well, decimals come into 2 forms. I want to start by talking about fractions. Fractions include finite decimals, like 0.5, which is the fraction 1/2, and even infinite decimals that have a pattern, like 0.3 repeating. They go on forever, such as 1/3. Anything that can be written as a fraction is classified as a rational number. Rational numbers include everything that you see here. That's why everything's in a circle, because 1/2 is rational. It's written as a fraction. -2 is rational because you could write that as -2 over 1. All right. We've got all whole numbers can be written as fractions. Any whole number can be written over 1, making it a fraction. So all of these can be fractions. Even 0 over 1, you could technically write it so it looks like a fraction there. So every single one of these numbers that you see in front of you is a rational number because it can be expressed as a fraction. What about numbers that can't be expressed as a fraction? Well, we got pi, square root of 2, square root of 3. These are decimals that go on forever and never, ever, ever repeat. All right? Therefore, they cannot be expressed as a fraction. These are referred to as irrational numbers. All right? And these are outside of the rational number circle. Notice so far in the rational circle, we were including all the numbers that we talked about prior to that point. We were just adding to the set. Now, all of a sudden, we have a completely separate set of numbers. These two are not attached. In fact, they are opposites of each other. Rational numbers and irrational numbers are opposites. That prefix IR, meaning not or opposite. So in this case, not rational, irrational. Therefore, we either got a rational number or you have an irrational number. So one of the things that we'll ask you to do is to classify, is the following number rational or irrational? Well, if you get a number, just check. Can I express it as a fraction? All right. In other words, is it a whole number? Then it's rational. Is it a fraction? Then it's rational. Is it a finite decimal? Then it's rational. Is it a repeating decimal? Then it's rational. Any number that is a decimal that goes on forever and never ever repeats is irrational. Typically, you'll see that with pi. Anything with pi, 3 pi, all right, 4 pi, all right, pi divided by 2. All of those would be irrational. They all include pi. Square roots of numbers. Anything that has a square root of a non-perfect square number is irrational. All right, but Bottom line, if you can't tell rational versus irrational, plug it into your calculator and then try to use the F to D button. All right, the F to D button will allow you to see if it is rational or not, because when you type in that F, and it's got a little arrow, arrow, D, I think it's a lowercase d. All right, and if you type that in and it works, then great, you got it. And then it turns it into a fraction, and you can see, hey, this could be expressed as a fraction and therefore rational. All right, so let's look at classifying a little bit further. If I asked you to classify the number -1, well, -1 is right here. So start in that circle and go out. -1 is an integer that is rational. All right? Let's take a look at another one. What if I asked you to classify 3? Well, 3 is a natural whole number that's an integer and rational. All right, what if I asked you to classify 1.5? Well, 1.5 is going to be a decimal like 0.5. Well, that is just rational. All right? What if I asked you to do square root of 2? Well, square root of 2, irrational. That's it. All right? We will add on to this. There's one there. We are going to open up the system a little bit more, okay? Because as we go into this here, now we see the whole number system includes a little bit more than this. All right? The whole number system, now we have what we looked at, which was our real numbers. Everything that includes rational and irrational numbers is part of the real number system. It's called real because we have imaginary numbers as well. Imaginary numbers and real numbers are opposites, just like rational and irrational was. That's why it's a separate bubble. So now if I asked you to classify something like -1, you'd say -1 is an integer that's rational and a real number. Always start in the circle where it's at and move out. All right, what about the number 0? Well, 0 is a whole number that's an integer that's rational, that's a real number. All right, if you want to go further, you could say it's a complex number. Every single number is complex. All right, what about 3? 3 is a natural whole number that's an integer, rational, and real. Square root of 2, again, just irrational number that's a real number. All right, irrational number that's a real number. So start in the circle where that number would be and work your way out. Every single circle that is inside of is part of that system, all right, or set rather.